Hello, and welcome to today's expert panel webinar on emerging IoT technologies, smart SIMs, eSIMs, eUICC, and 4G. My name is Jeremy Cowan. I'm editorial director and co-founder of IoT Now, and it's my very great pleasure to be your moderator today. Thank you to everyone for joining us today. We have one of our biggest ever attendances from right around the world, and that's purely because we've got a great discussion for you. It's brought to you with Sierra Wireless and Aidon, and backed up by independent analysis from Beecham Research. So the first thing to do is to introduce you to our three speakers. They are Robin Duke-Woolley, CEO of Beecham Research, who many of you will know, and he will be speaking first. It's very good to have you here, Robin, as always.
Great to be here, Jeremy. Thanks.
And I'm delighted to welcome back a speaker we've enjoyed here before, Cyril Hullin, Sierra Wireless's Vice President of Product Strategy and Marketing for Cloud and Connectivity Services. That's quite a title, but it's great to have you here back, Cyril.
Thank you, Jeremy. Thank you very much. Great to be here.
And it's my pleasure to welcome a new face to our webinars, one with plenty of real-world experience deploying energy meters and head-end systems, and he is Herman Slutsveen, General Manager of Aidon. Welcome, Herman, too.
Thank you very much, Jeremy.
Today, we're looking at emerging IoT technologies, including embedded SIMs and embedded universal integrated circuit cards. Let's just call them eSIMs and eUICCs. You know that selecting the right tech is going to be critical for your Internet of Things initiative, but the question in many minds is, how do you make the right choices in smart SIMs, eSIMs, eUICC, and 4G? Well, our guests are here to tell you exactly that. This webinar is being recorded, and you can access it again from tomorrow via iot-now.com. We also want to know what you think, and we've allowed time later for your questions, so please start sending them to me now. After the presentations, I'll put your questions to our panel. Just click on the questions button in the meantime and type your query into the window. Any that we don't get to will, of course, be passed to our speakers so that they can answer offline. Finally, if you're having any technical issues with audio or slides, you can also use the question window to get advice from our wonderful tech support team. Now, we have our audience poll. I did say at the beginning that we like to have your opinion, and this is no exception. We're going to ask you in a moment to click on answer A, B, C, or D. In fact, you could do it now. Whichever is closest to your experience, and we look forward to seeing the results immediately. The answers are, of course, anonymous. So the poll question is, at what stage is your own IoT deployment? Is it A, I am already using connected devices? B, I already have an IoT project underway? Is it I plan to start an IoT project in the next 12 months? Or I am doing research and not yet sure about an IoT project? So at what stage is your IoT deployment? Let's move quickly through to the results and see what initially we hear from our audience. And we have a pretty strong contention that audience members are still doing research at 33.7% and not sure about an IoT project yet. Maybe they'll know more at the end of this session. 31.6% say, I am already using connected devices, which is very encouraging. And 20% on top of that already have an IoT project underway. Just 15% will not quite have plans to start it in the next 12 months. Robin, is that in line with your expectations?
Well, I think that's very good, actually, that there are so many people that are researching and looking for new IoT uses within their organizations. So that's a little bit higher than I would have anticipated, but that's really good.
Yeah. I'll just ask you quickly, Cyril, as well. Is that the kind of figures that you've come across?
Well, yeah, yes and no. Obviously, as mature prospects and customers, we very often have mature projects with a mature technical ecosystem, but we also every day and every single day face brand new use cases, ideas, projects at their very, very nascent phases. So bright new, very exotic ideas every day. But still a now mature market with some heavy mature markets in existence.
Yeah, and Herman, is that the sort of figures that you expected to see?
Well, yes, I think so. We have, since we have been in the market for some time, we have of course seen a lot of people coming up with, or organizations coming up with new services. But I expect that is the case.
Yeah. Okay. Well, look, thank you, everyone. Let's crack on with the webinar. We'll start with Robin Duke-Woolley of Beecham Research, and afterwards, I think Robin will hand back to me. But Robin, over to you.
Very good. Yes. Well, this is just a very brief introduction to Beecham Research, actually, so that people know who it is that's talking to them. So we're based in London and in Boston, US, and we operate worldwide. We're specialists in M2M IoT, in strategy consulting, market analysis, and research. That strategy consulting covers both system suppliers or market players, but also increasingly users and developing a market strategy for users. We've been researching M2M and IoT for 15 years, since 2001. We were the first analysts to study cloud-based M2M platforms. We've been doing that since 2008. We're leading analysts in IoT security, satellite M2M, wearables, smart farming, energy, and that's in addition to cellular and all the normal stuff. And our market segmentation is our sector map, which is the left-hand chart, which is very well known in the marketplace now. You can Google it. And on the right-hand side, we have an increasing number of sector charts, specific sector charts, which are much more user-focused, which look at the uses of IoT in different parts of that industry. So we have a very detailed manufacturing chart, also a retail chart. We've got a healthcare chart, an energy chart, and lots of others in other parts of the market as well. So you can visit our site to get more information on that. So back to you, Jeremy.
Thank you, Robin. Yes, lots of sectors covered there. Let's hear a little bit more and understand a little bit more about Sierra Wireless. Over to you, Cyril.
Thank you. Yes, so a few words on Sierra. We've been in the wireless space for now much more than 20 years. We've always been leading in innovation and very first to market with new technologies. We're number one in terms of market share for wireless embedded modules, and it's been the case for the 5 last years, and providing about a third of all embedded cellular devices and modules across the globe. To date, we have shipped a little more than 120 million M2M devices, and we expect to ship another 120 million devices by 2020. So our offering is a comprehensive and now exhaustive portfolio ranging from wireless devices, embedded modules and gateways, open source embedded software platforms, and more recently, so sorry, I forgot to browse the slides, and more recently, investments and developments into the wireless space. So our portfolio today is composed of not only modules and hardware, but also a complete set of services from cloud applications and services and connectivity services. So Sierra is now an MVNO, full MVNO with global footprint. We have more than 2 million subscribers with about 1,000 customers worldwide, which gives us a scale to address both from small customers all the way up to large OEMs and across the globe. So Sierra is focused on providing end-to-end services and solutions for IoT players, from devices, modules, and gateways, up to the connectivity, device management, cloud applications, and services for IoT industrial players. Back to you, Jeremy.
Thank you, Cyril. And let's hear a little bit from Aidon. I could do with learning a bit more about what you're doing there, Hermund.
Yes, Aidon, as you know, is a Finnish company. Has been in the market for about 10 years, and is now established as a market leader in the Nordic energy market, with our major customer bases in Finland, Sweden, and in Norway. From my accent, you might hear that I represent the Norwegian office. And in the Norwegian market, we have, during the last 3 years, gained almost 50% market share. And we provide our solutions and services to the largest DSOs in Norway, the energy distributors. So, our solution is based on a module meter solution, where we have combined an advanced energy meter and a separate communication module, and pack that into a common under a common cover. So that solution has been proven to be quite successful, and by utilizing our mobile services in Norway and Sweden and Finland, we provide a transport layer that brings meter values into the central processing site. We have spent quite a lot of time of developing our services, and it's been the last 3 years that we have really had success. So we are quite happy what the situation is now. So back to you, Jeremy.
That's very interesting. Thank you, Hermund. Well, today's event is structured around 3 key topics. And what we want to do is to address them one by one. The first is key challenges with IoT connectivity. The second is roaming SIMs versus multi-operator connectivity. And the third is the benefits of eUICC, plus the challenges and some use cases. And I'm going to put these questions to our panelists, our experts. The first being key challenges with IoT connectivity. The first question is for you, Hermund. What were Aidon's technical and operational connectivity challenges?
Yes, our biggest technical challenge is having a reliable communication solution, because we have to ensure that 99.9% of the readings of these energy meters we have out in the market, 99.9% of those are collected and delivered to the central site at 5 a.m. every day and 365 days a year. So reliability is a very important factor for us. And in our systems, we have up to 1.2 million meters in a single system, so you can imagine. We've been looking at the different technology providing this communication solution. So what we ended up with was to build a resilient and a meshed radio network for collecting the values from each of the meters and transfer that to a local concentrator placed in the DSO's different sites. And then we use mobile communication into the central headed system for processing, using the 2 or 3 or 4G as a carrier, and using connectivity services from Sierra Wireless that concentrate the traffic through the VPN, the APN, and send that into the central processing center. So I think the biggest technical challenge was to create this communication solution that is really reliable. Back to you,
Understood.
Jeremy.
Thank you. There's an aspect of this that I want to ask Robin about, and that is the overall picture, Robin. What trends are you seeing at Beecham in the market regarding IoT connectivity?
Well, okay, yes, I mean, there are many, and I could talk for an hour about them, but let me summarize just a few. Basically, I mean, there's a huge increase overall. There's lots of talk about 20 billion connected devices by 2020 or 2025 or whatever date you like to gain, but basically that means there's an awful lot of new connections, and that means that there's an awful lot of activity in the marketplace. It does raise some questions about how do we implement and maintain those sorts of numbers. How do we implement them in the first place? That's an awful lot of connections to make. And how do we maintain them if something goes wrong? So if the connection goes down for some reason, how do you fix it in an economical way? That needs a lot more automation and lots of thought. And I know that there is a lot of thought going on in that area, but that's one area that we probably don't think about too much, which is nevertheless going to be critical for the activities to actually work. But then there's an increasing focus on development of low data rate, wide area applications. So there's a whole new range of applications that weren't really possible before because the technology wasn't particularly cost effective. So we've had LPWA around for a couple of years now, and that's beginning to mature. So there's a lot going on that side, on the unlicensed spectrum side, and now we've got the mobile IoT technologies appearing over the next couple of years to provide the licensed spectrum alternatives. And so there's going to be much more of a focus on low data rate, wide area applications to complement what we've had in the marketplace up to now, which are rather higher data rate applications. And then at the same time, of course, those established applications, many of them are looking to become richer content. So just to take one simple example, fleet management, which has been around for some considerable time. There's now efforts to make that a much richer content with lots more inputs, sort of from the cab and from the trailer, from the load at the back, and so forth. So there's a lot more going on now than has been the case, and that means, of course, faster speeds. So that's the need for 4G and LTE and beyond. So we're seeing a diversity in the marketplace developing. Lower speeds for new applications that people have not really thought of before because they weren't really very cost effective to implement before, and then higher speeds for established applications as well. And then the last thing that I'd say is there's a lot going on in security. Security is a really big issue, end-to-end security. And it's not just for control. So we all think about Jeeps going off the road and things like that, but that's not really just the point. We're moving to greater use of real-time data, and we need to be sure that data is not compromised in any way. So it could be from very simple sensors, and we need to make sure that that data is not corrupted in any way. So there's a much greater focus on security of the overall solution going on. So that's a thumbnail sketch. Many more, but that's just an idea. So back to you, Jeremy.
Robin, heck of a lot of themes there, and very good ones. I can see I'm going to have to ask you to put your pen to paper for the next issues. Cyril, what challenges are you seeing from your customers?
Yeah, so I think customers, innovative utilities like Aidon are interesting examples which sum up the challenges and needs of our customers today and tomorrow. And those can be summed up into these four families. First, what do I do if I need reliability in terms of coverage, whether it be for indoors, deep indoors coverage, being able to cover rural areas, urban canyons? How do I cope with wide gray zones? In terms of quality of service, data quality, what can I do to optimize my data availability rate and overall the quality of service of my connections? flexibility is key and more key, and this means many things. How can I cope with, and it's especially the case for utilities with very long lifespan fleets of machines which need to stay on the field without any risk of needing a truck roll, and how do I cope with technology continuity and eventually not locking myself with MNO XYZ. And simplicity obviously is very key to enable the emergence of new business models, of new applications in terms of global coverage, in terms of SIM device connectivity, lifecycle management, troubleshooting tools and capabilities. So in order for industrial players not coming from the telecom world to be able to easily deploy connected devices without heavy investments and without developing skills which are not in their core business. On to you.
Excellent, thank you. Now we come to the second of our key topics, which is roaming SIMs versus multi-operator connectivity. And I want to bring this back to you, Cyril, straight away. What is the difference between a local roaming SIM and a multi-operator network SIM?
Okay, so we have to dive a bit into the details of the technologies. First, I will try to draw here the way a roaming SIM behaves, standard roaming SIM behaves, which is basically the behavior of the SIMs we have in our phones, in our pockets, when in a international roaming situation, when abroad, and compare it to what we have developed, which is a SIM, or what we call our smart SIM, with an embedded applet, which enables a specific behavior so that the attachments procedure is tailored for machine-to-machine applications. So roaming SIM, when trialing a network attachment, will probe a list of preferred networks, on its domestic market, obviously will attach to its home network. When abroad, will select among a certain number of available networks according to a list of preferred networks the number one, and in case of unavailability of network number one, we'll try number two or number three, etc. Yet more and more we see a second mechanism on top of this list of preferred network, which we call signaling steering, which forces, or the other way around, which prevents the attachments to network number two or number three after a certain number of trials, with the force of what we call signaling steering, which is a kind of invisible hand which forces to some extent the attachment to network number one. And this really corresponds to the nature of roaming, of international roaming between operators. So this has a clear impact on the time to attachment to network number two when network number one is not available. Now the second line here describes the smart SIM behavior. So the SIM will drive the module and will scan the various networks it has in visibility. Will log all of these networks. Will eventually log some QoS criteria which it will have probed, and will select the network providing the best QoS compromise according to the operational or business logic of the device I'm operating. So it's we're not leaving the attachment procedure decision to a list of preferred networks corresponding to the agreement to the agreements an operator will have cracked with its partner operators, but we will let that be done by a kind of a decision engine, an embedded decision engine on the SIM, which drives the attachment according to QoS criteria. That's it.
Okay,
Jeremy.
I think that's a good moment to come back to you, Robin, to find out about how significant the embedded SIM is for the IoT market.
Yes, indeed. So Cyril was talking about other forms of SIM. So this is the embedded SIM, just for those that are not aware, it's a component soldered onto the board of an electronic device and then updated over the air. So we think that, in short, it's very significant for the IoT market, but it's not, of course, right for all applications. But we think that it's going to be right for a number of very important applications coming up, and I'll talk a little bit more about that just now. So it really provides the opportunity to update over the air wherever the object is. It could be underground, it could be up a pole, or it could be in any sort of other inaccessible place. So rather than changing SIM cards, you can just update all of that data over the air, and then it's done. So you can do it in situ, which makes it much easier to handle, to manage. As well as that, because it's a component, it streamlines the production process compared with SIM cards. And that's very important, for example, in the auto industry, and that's where it started to be used first. So it drives the whole thing about having to change SIM cards and things like that away, and it all becomes a solid state type of situation. In addition, in the case of retail products, it opens up general retail as a channel to market, because the retailer doesn't need to get involved in SIM card provisioning. So it's not a specialist activity anymore. It's something that anybody can do. Well, in fact, they don't need to do it at all because it's built into the product. And the idea then is that you take the product out of the box, you put the batteries in it, you switch it on, and then it effectively sets itself up to the operator that's required, the tariff plan, and so forth that's already been agreed. So it's a much easier way of getting products out in high volumes through very disparate routes to market. So it's that means it's very compatible with the manufacturing process and for high volume products, and I think that means it will help to accelerate the growth in the market. So that's really the key point. How significant is it? Well, significant for accelerating growth in the market. Then one last point that I'd like to make is talking about mobile IoT applications. So I talked earlier about mobile IoT technologies coming to the market. That's NB-IoT and LTE-M and so forth. And they're going to become very significant over the next 2 years in the market. And these are low cost and need as much automation as possible to get working in high volumes. It's much more of a high volume type of situation. And I personally believe it's inconceivable that this would be economically viable to do using SIM cards. It is a personal view, but I think that embedded SIMs are going to be an essential enabler for those types of technologies. So we will see these shipped out as part of the mobile IoT technology deployments, and then updated and provisioned over the air. And that's a much more automated and quick way of doing it, and economically viable for those low-cost types of connectivity. So I think that the future of embedded SIM is very bright, and will show lots of opportunities for growth of the IoT market. Back to you, Jeremy.
Thanks, Robin. I think the over-the-air provisioning is such an exciting aspect of this, but that's for another day. Could you please help me with this, Herman? There's a couple of aspects of this that I wanted to look at. Did you look at roaming and multi-network SIMs, first of all?
Yes, absolutely. We looked at the roaming and multi-network SIMs all the way, so to speak. Obviously, roaming from a mobility point of view is obviously not of interest to us. We have the fixed households and fixed installed meters. But to get the best possible connectivity at any time and base that on the signal strength we have from the mobile operators, and choose between the operators any particular site that has the best connectivity is, of course, essential for us. So to build the resilience and to build the connectivity itself. So a solution with a multi-network SIM and the roaming possibilities as part of that gives us the possibility to utilize the two physical networks that, especially here in Norway, is currently, in the best possible way. And based on that, give us the best connectivity parameters at any time. Back to you, Jeremy.
Thank you. And I guess that pretty much answers how you selected your connectivity provider. Is there anything you want to add to that?
Well, we did a process a procurement process back in 2014. At that time, we found wireless main gate having the best offer in the Norwegian market, and we signed a deal with them for the service. After that, Sierra Wireless has acquired wireless main gate, and we have obviously continued with the contract with them, and we are quite happy with that. So, but we did not try to establish a service ourselves. We found to have a partner is essential for us. Back to you, Jeremy.
Thank you. That's excellent. Which brings us neatly to the third of our key topics. And I'm going to go to Cyril first on this. Cyril, the eUICC benefits, challenges and use cases. That's the topic here. Can you shed some light on this? There's been an awful lot of confusion in the market. What is eUICC?
Sure. So first of all, to start with, eUICC is not a form factor. An eUICC can be both a plastic SIM or an embedded soldered SIM. So, and a standard eUICC may be a soldered SIM or a plastic SIM. An eUICC, so first, why did we need a new type of, new philosophy of SIM, I would even say. Until now, a SIM was attached to a carrier, to a subscription. There was no possibility of portability between operator A and operator B. Switching operator meant switching SIMs, which meant in the IoT space a truck roll in order to swap the active operator in a given device on the field. So an eUICC is a kind of container on which we can load and activate a SIM an MNO SIM profile remotely. So load over the air, provision, activate, deactivate, remove SIM profiles remotely, and that's very key for the future and the scalability of important IoT projects. So how does this work more precisely? Let's say we want to swap the active profile in a given SIM from operator A to operator B. First, with a simple set of APIs, we will upload on the SIM remotely the MNO profile, the MNO SIM profile of operator B, using obviously the connectivity of operator A, load it onto the SIM, and then activate this new profile, which with the action of one API will transform into the SIM of operator B. So with a simple, philosophically with a simple set of APIs, send, activate, deactivate, remove, we can swap the active profile on a given SIM on the field from any operator to any operator. So that's the magic of eUICC. Back to you.
Thanks very much, Cyril. I think I've overshot there. Yeah. Aidon's answer here is what I'm looking for, and that is to understand from Herman, have you evaluated eUICC yourselves yet?
Well, we did that originally. That was one of the criteria we had to have the possibility to change the operator and get the competitive advantage from that. And you must remember, we bring that towards our end customer again. So, but it comes with a price to have the opportunity to use it in the SIM. And later we have evaluated that functionality together with our end customer and looked at the cost benefit of that. We have concluded that we will leave that up to Sierra Wireless to use the opportunity to provide the best service at the best price. And let them sort of prove that they are able to do the best deal with the operators. So we don't deal with that at all. So I think this functionality is more for Sierra Wireless to utilize than for us. We still have the opportunity to turn the deal with Sierra down, but I don't see any reason for doing that. They do perform well, and we are quite happy with them. And as long as we can keep this good relation, I think there is no reason for us to think in that direction at all. Back to you, Jeremy.
Thank you. Well, you've neatly covered the second question, which our audience can see. Do you see Aidon using eUICC in the future? Clearly, you don't rule it out. It's a question of Sierra making the case for it. I want to ask Robin about this. Robin, what are the benefits of adopting eUICC and the best utility use cases?
Yes, indeed. This is quite an involved subject, and I should say straight at the outset that there is a difference between embedded SIM and eUICC. As Cyril was saying, eUICC is not a form factor. It's more of a concept, and it's over the air and updating and so forth. Whereas embedded SIM is a component. So that's the difference between them. And we've been looking at this as part of a study that we did recently, which was commissioned by ESMIG, GSMA, and SIM Alliance. There's a report now that was published in November 2016, and it's available on the GSMA website and other websites as well. And I'd just like to run through some of the findings from that. So we looked at the 14 key benefits of the GSMA embedded SIM specification, which includes the eUICC for utilities, specifically for utilities. And what we were looking at is how can the embedded SIM, or actually in this case it was the eUICC, but we were looking at the embedded SIM form factor. So we were looking at the soldered component form factor as opposed to the other form factors. So bear that in mind. And we were looking at 4 key factors. Improving reliability and reducing site visits was the first one. And on the screen you'll see the first 3 of those benefits. So late operator binding, which basically means that the devices can be shipped direct to site and the network operator is updated over the air on installation. So you don't have to have a pre-provisioned SIM card that is sent out to the site. The whole lot happens once the device is, in this case a meter, is on site and ready to update. And I think this is a different situation to Aidon, because this is operators working directly with utilities. So the utility is looking for freedom, the ability to change the network operator, for example, at the end of a contract before the start of a new one, and getting provisioning directly from the operator. Whereas the situation with Aidon, there's Sierra Wireless is in the middle there and providing alternative connectivity through a number of different operators. So as Helmut was saying, they'd be looking for a best deal and therefore overcome it in a different way. So, you know, the embedded SIM is really useful in some situations and you know, can be overcome in others as well. So anyway, improving reliability and reducing site visits. Late operator binding is the first one. The ability to change the operator and the information for that is also downloaded over the air, so there's no site visit required. That would be typically at the end of a contract. And then reliability, because the SIM card and holder is not as reliable as a fixed unit. So it reduces the need for costly site visits if you can do that. Then the second area was improving security and trust, and then we had 4 areas here. So low cost and risk of security breaches, and that brings security benefits of the mobile network, authentication and stuff like that. So the combination of using the embedded SIM and a cellular network provides that kind of benefit. Then trust and confidence in the data collected, very important aspect, but that's also combining the two together, combining the embedded SIM with the cellular network, so especially when used for billing and fault identification. Very important points there. Then it's theft resistance, theft protection. It's very difficult to steal the physical unit because you can't get it out. It's embedded in the board and very difficult to then use fraudulently. Whereas a SIM card can be taken out and used for other purposes, and has been done in the past. So the opportunity to use fraudulently. And then tamper resistant, so similar as the previous one, but a different sort of benefit, and that means it's less vulnerable to tampering, and enables the device to be waterproof and ruggedized if that's required. So it's a different set of benefits there. And then we move on to the second set, and here we have reducing cost and complexity as the first one, and then reducing commercial risk and increasing commercial flexibility as the second one. So that means the total of 4 groups. So taking C, which is then the third group, reducing cost and complexity, lower cost because it replaces the SIM card, the holder, and the wiring. It reduces the bill of materials for devices by up to about $50 per device, we believe. So in very high volumes, that's an important factor. It's also a small form factor. It's 12 times smaller than a typical SIM card, and that means that it's pretty ideal for mass volume devices. So then the final group is reducing commercial risk, increasing commercial flexibility. Often there's lower power consumption, and that's important for long battery life. Safety in hazardous locations, such as gas meters, for example. It's safer than SIM cards in that kind of situation. Also, certification is much easier for this type of device. For hazardous locations, it's easier and quicker to do. And then the connection with cellular communications, which is ubiquitous, particularly with the introduction of mobile IoT technologies, the ones that we're talking about coming in the next few years, which allows sort of deep penetration of buildings, and there's no essential geographic restrictions. And then cross-vendor interoperability is really quite an important factor here, because it means that there is a market, an open market for these. You can mix and match from different operators, so there's full interoperability and interworking between different vendors in the ecosystem. So that's a sort of thumbnail. It's quite involved, and there's quite a lot going on there. So we've tried to summarize that in a chart, and we've been looking at 5 different use cases for all of these. So we have the 4 groups there on the left-hand side of this chart, and then we have in the middle we have those sets of benefits that I've just been through, and then on the right-hand side we have a whole load of dots, and we've set those against 5 different use cases. And if you can read those, because it's a little small on the screen, the first use case was smart metering. The second one was demand response. The third one is distributed energy resource management. The fourth one is home energy data management. And the 5th one is commercial and industrial energy data management. So these are all use cases of interest to utilities, different utility roles, particularly in the distribution role and the retail role, but also the transmission role. Those 3 more than generation role. And you'll see that smart metering is there's benefits for the smart metering case for all of those, uses all of those benefits that I've just mentioned, whereas the other ones are for less of them, but nevertheless very significant. So overall, where the use cases are of particular interest to a particular utility, then those benefits will be of particularly relevance for those use cases, and therefore the role of the utility in operating those use cases. So that's the point that we're trying to make there. And again, I say that the report that we've just done is available for download from the GSMA site and other sites. Over to you, Jeremy.
Thanks, Robin. I think we need to move quickly on because we're going to lose time for our questions if we don't. And that is a moment to ask Cyril, what is the difference between a local roaming SIM and a multi-operator network SIM?
Okay, so that I've a bit addressed during my previous slides. A roaming SIM will attach according to the logic of roaming, which is attaching according to the list of preferred networks, the location update criteria, which is availability of voice and SMS. A multi-operator SIM, and the way we understand it, embeds a smart applet which enables the smart selection of the visited network according to QS criteria. Now, if we talk about the eUICC concept, which has a great promise, which is very useful for to unleash and for the emergence of new business models and new applications. So to give power, to give the grip of the SIM to the industrial player and not to the MNO. This constitutes so this is a great value for the industry, but it consists of a certain number of challenges in terms of integration. The promise of the latest flavor of the eUICC standard enables full interoperability between vendors if different vendors provide the module, the SIM card, the eUICC subscription management platform, the connectivity, the mobile operator and connectivity provider. But all this, in order for it to deliver its promise, needs a prior complex integration and to have close look into the respect of the standards. And that's what we've endeavored to do at Sierra Wireless. We've understood the complexity of these challenges and are in the process right now of integrating a full GSMA 4.1, 4.2 eUICC infrastructure for subscription management integration into eUICCs, and we are about to launch. We have already tested a certain number of scenarios with a certain number of MNOs across the globe to provide eUICC capabilities to some customers. So it's a complex ecosystem again, with from the SIM vendor, the module vendor, the subscription management infrastructure, the MNOs, to integrate and to guarantee to the end user, to the industrial player, that during the lifetime of a device, which could be 5, 10, 15, 20 years, the remote provisioning capability to swap the active MNO will be possible, regardless of the pieces of the puzzle which will constitute the eUICC ecosystem. So to conclude about this, in order to simplify and ensure the emergence of these new projects, we have integrated and pre-integrated and pre-tested the whole chain from the module to the SIM, embedded SIM or plastic SIM, including the eUICC capabilities, the 3.1, 3.2, the cloud platform with the APIs and remote provisioning, remote subscription, OTA subscription activation on our AirVantage platform, and we also provide global connectivity as one of the potential profiles we can load on the SIMs for our customers. So this is ready for Aidon or for any other customers, or soon to be ready to be deployed across the globe. And back to you, Jeremy.
Thank you, Cyril. Look, this is great. We've got an awful lot of information covered, but there are a ton of questions, and you've been very good about sending in your questions to us. So let me move without any delay to a question for Cyril. How are OEMs reacting to the eUICC to remote SIM provisioning solutions?
Well, generally speaking, OEMs have been waiting for that type of technology for a long time. We have started speaking about eUICC probably 6 or 7 years ago. Initially, it's a technology, or it's a concept that was initiated together by automotive makers, car makers, and the telco industry and the GSMA. We have seen until now several flavors of eUICC, with the first generation, second generation of the standard, which had a certain number of key weaknesses in terms of interoperability, meaning in order to deliver the promise, the MNOA needed to have SIMs from the same SIM vendor as the vendor providing the infrastructure, and the recipient, the operator B, needed to be compatible with the same infrastructure and SIM profile in the way he manages, in the way the operator manages his SIMs. So a real lack of interoperability. Yet, finally, with the latest flavor of the standard 3.1, 3.2, we are at a level of full interoperability, which has been tested. Plug tests and portability interoperability tests have been done between SIM vendors, SMSR, SMDP, which are the two key nodes of the eUICC infrastructure, and many MNOs across the globe. So OEMs have been waiting for that for a long time, for the promise of the portability of eUICC. It's now ready, finally. It's come out of the, I would say, GSMA oven just before the summer, been integrated by the ecosystem during the past months, and we will probably be one of the first operators to launch it and to propose eUICC as a mean to deploy connectivity for our customers, OEMs, large and small.
There's a question for Herman. What are the key learnings that Aidon has made in your IoT project, Herman?
Well, we have, of course, our focus is on our own products and our core strength. And I think for us, it's been very, very important to get partnerships for providing services that we are not able to do ourselves. So by achieving and utilizing technology through good partnerships has been essential for us, and it has enabled us to bring products and our solutions into the market more quickly and with the quality than if we had tried to do that ourselves. So I think good partnerships for us has been important here.
This is an interesting one. It takes me back to you, Cyril, please. The question from our questioner is, what kind of value can MVNOs add to their offering that would make them stand out from the carriers who are essentially competing on price?
Well, it's a good question, but it's a very broad question. There can be many dimensions in the value they can add. The first one is obviously neutrality. MNOs, generally speaking, are going or will be going the eUICC path, but I would say backwards for obvious reasons. MVNOs are and have been in a more neutral position and have always been, with very often multi-sourcing. In our case, the promise to deliver connectivity services across the globe, and in most countries connecting to all networks without any economical bias, meaning that we serve all operators, we serve the connection to all operators across the globe without any roaming agreement bias, but only with an attachment criteria, which is QoS and QoS-based steering through our embedded SIM smart steering applet. What MVNOs can offer also is neutral access to a catalog of MNOs so that an industrial player may swap the active profile from that of the MVNO to MNO A, B, C, or D, and it may be triggered or motivated by obviously economical reasons or the services provider do not suit what the expectation of the OEM, but also in some cases by regulatory reasons. For example, in Brazil, a local profile is necessary to provide IoT and end-to-end services in Brazil. So the capacity to swap an MVNO's active profile by a local Brazilian subscription is key. And this is much more easy to produce and provide by MVNOs than it is by most operators, which again will go down the eUICC path rather backwards than with energy.
We've got so many questions. We're doing really well, but we're tight for time. So I'm going to ask every answerer to give it only 30 seconds to a minute per question, please. This one I think would be probably best directed to Cyril, and it's, are the initial eUICC solutions likely to support LTE Cat M1, NB1, or some other low-power, wide-area solution, and what sort of power budget will be required? I know that's an awful lot to ask in a few moments, but what can you say, Cyril?
Okay, so first, the access to LTE Cat M1, NB-IoT, NB1 is more a question of roaming, national roaming, international roaming agreements. So by nature, an operator deploying LPWA capabilities on its home network will have the capacity to provide this technology on eUICCs from day one. In a roaming context, which would be the case for a roaming IoT SIM or for our smart SIM, for example, it is subject, obviously, to the opening of international roaming for LPWA solutions. And that will come over time. We expect to have the first international roaming agreements on LPWA in the middle of next year. We probably will be doing some tests in Q1, Q2, and then gradually, like it was the case for 4G, networks will open themselves to international roaming for LPWA over time. But starting probably Q2, and then a gradual ramp up to open international roaming for LPWA.
I've got a question for you here, Herman. We talked earlier, or you did, about your past challenges in implementation. Can you just cast your eyes forward and tell us what you think are the current and future likely greatest implementation challenges? And again, if you can keep it brief, I'd be grateful.
Yeah. Well, I think we have currently quite a well organized system to implement our deliveries, so it works quite well. I think one of the major challenges can be that if something goes wrong in this quite a long chain of communication, can be a challenge to actually try to resolve the problem and understand where you actually things are stopping up. So that can be a challenge for us, and we need to have very good working relationship with our end customers, of course, and as well as our partners, in order to sort things out when things doesn't work. So I think that is the main challenge we have currently.
Thank you. I've got a great question here from a well-known company in North America. Cyril, I'll ask this of you. What is the expected life cycle of a device with embedded SIM, and how should we think about network changes over time, creating need for device replacement? Two questions in one: the life cycle and creating the need for device replacement.
Tricky question for 30 seconds. Yeah, indeed, two questions in one. The eUICC life cycle, I would say that there's probably in the question, the idea is the use of what we call the insurance model. So using the eUICC capabilities to swap the active profile in a, I would say, a wave mode, in a batch mode, for sourcing policy fulfillment. So after 3-4 years' time, an industrial player decides to launch an RFQ and eventually decides to deploy for its future deployment, but also swap the install base thanks to eUICC with a new player. And that is the insurance case. So swapping an install base, swapping a whole fleet overnight from operator A to operator B. And this can happen, and generally speaking, will happen according to a kind of a sourcing cycle. Other than that, the eUICC life cycle is the same one as a standard SIM. And the second part of the question, I guess, is the sunset of technologies. So, which obviously short term is the impact of 2G sunset in the US for AT&T and T-Mobile. Not to talk about CDMA. At some point of time, it will be, and it might be the case sooner than expected, of 3G in Europe or in the US. And one day there's sunset of 4G. And the beauty of eUICC and eUICC ported by some MVNOs is to kind of mitigate the risk of the sunset of these technologies, because a SIM which will be first portable across MNOs with as an active profile different MNOs or MVNO profiles is one strength. The capacity to have on a module 2G, 3G, 4G technologies embedded on one module is the best future-proof insurance, and the economical insurance to be able to swap the active profile from the MVNO to a given MNO to eventually match regulatory conditions in tricky countries like China or Brazil, or to match sourcing policy evolutions. Are the keys to this to the security of a long lifespan deployment. I'm not sure it answers the question, but if that person can contact me directly, we can probably discuss for a few tens of minutes about that topic.
I think you've done a pretty fair job of that. That's fantastic. And thank you, all of you, for managing to keep very complex answers to a time. I've pulled rank and we've overrun slightly over the top of the hour. I thank you all for your attendance. The aim today has been to explain, obviously, some of the emerging IoT technologies, and clearly we've heard a lot about not just the challenges and also the opportunities, but sadly, we are out of time. Can I just ask you to bookmark our website for further information on all of this at iot-now.com, and you'll find that this webinar is being streamed from that site as from tomorrow. Obviously, it just remains for me to say a huge thank you to our speakers, to Robin Duke-Woolley of Beecham Research. Thank you, Robin.
Thanks very much, Jeremy.
To Cyril Hullin of Sierra Wireless. It's been a pleasure, Cyril.
Thank you very much.
And last but not least, to Herman Slutzveen of Aidon. It's been great to have you here, Herman, and I hope we have you back again soon.
Thank you very much.
Most of all, ladies and gentlemen, I want to thank you for joining us. Keep safe. We really do appreciate the time you spent with us. And from everyone here at IoT Now, enjoy the rest of your day. Bye for now.